Do you know how many millions of acres of forest burned in North America in 2025? 8.9 million in the US and 13.3 in Canada. That's a lot of burned trees. So after hearing this stat, why would you build out of wood? It seems logical that wood and fire don't go well together. Well, that's why I'm here. Let me explain to you why wood and fire actually is not that much playing with fire. Let's go to the classroom. Welcome to Fire 101, a course on how does fire actually work. Before we start, any questions? Yes?
Hi. Yes. How do you create fire?
Very good. Let's talk about it. To start a fire, you need three things. You need oxygen, the source of fuel, and heat. And in our case, fuel is wood. And let's talk about the different stages of how fire actually functions. Stage 1. Pyrolysis. Pyrolysis happens when heat is applied to wood, and then the wood releases gases, mostly known as volatile organic compounds, and also releases a residue that is rich in carbon that we call char. Remember that, it's very important for later on. Stage 2, gasification. The volatile organic compounds mixes with the oxygen in the atmosphere with the heat and releases carbon monoxide, carbon dioxide, water vapor, and then a tiny bit of heat. And then we have the grand finale. Stage 3. Everything mixes together, combustion. Boom. Big heats, big lights, big fire.
Okay, now that we understand how everything works, why is it important? It's important because of that particular part that we talked about in pyrolysis, the char layer. When the char layer is produced, it actually is this layer of non-combustible carbon residue that is porous. This residue and this layer will protect the wood from both heat and oxygen, slowing down the combustion and therefore protecting the structural integrity of the timber. And why is this even more important? Well, it's because that through testing and building codes, we now know that mass timber such as glulam and CLT have a very predictable burn rate, 0.6 to 0.8 millimeter per minute. This predictable burn rate allows us to design buildings in such a fashion that they have a fire rating of 1, 2, and potentially 3 hours. Oh, now I hear what you're thinking now. Steel and concrete don't burn. Well, let's unpack that. First, let's talk about steel. Yes, steel doesn't burn, but if heated up to 500 degrees Celsius or 932 degrees Fahrenheit, it can lose up to 50% of its strength, meaning that in a fire, if not properly insulated, it can buckle and suddenly fail with no warning. Concrete, same story. Yes, it doesn't burn, but it's very subtle, something called spalling. It is when moisture and air is trapped inside the concrete, and when it's heated, this air expands, or the water, moisture, expands, becoming steam, potentially causing cracks and failure within the concrete itself, potentially affecting other elements within the concrete, such as rebar. Mass timber, on the other hand, that's a different story. Because of its predictable charring process, it actually is quite easy to model exactly how much strength it retains during a fire. It doesn't twist or crack unexpectedly. The failure is gradual and visible. That gives first responders time, occupants time, and you peace of mind. And yes, it's all been tested. Mass timber has to pass strict tests such as the ASTM E119 and the CAN ULC S101 to get its fire rating. You see, this isn't just theory, it's code approved.
Still curious? Want to nerd out with the pros and learn how to use mass timber right? Then join us at the Mass Timber Group Summit in Denver, Colorado. We bring together more than 400 industry professionals and 38 speakers to go over everything and anything mass timber. So if you're an architect, engineer, builder, developer, or contractor, it is the place to be. So, click the link in the bio to buy your tickets, and we'll see you there.